Today, we will be discussing the angle addition postulate, as well as congruent angles and angle bisectors. Let's review by talking about congruent angles. Let's start with reviewing congruent segments. When we talk about congruent segments, we are talking about segments that are exactly the same size and same length. So for example, if I have segment AB and I have segment CD here, I know they are congruent segments because we put tick marks on them, and the tick marks indicate they are congruent. So we can write segment AB is congruent to segment CD. Now that same concept which we learned previously can also be applied when we talk about congruent angles. Congruent angles are angles that have the same measure. We use arc marks to show that two angles are congruent instead of tick marks. So if you note here on the two angles, angle ABC and angle FED, they have an arc mark, just one single arc mark by the vertex, near the vertex of each angle, and that indicates that angle ABC is congruent to angle FED. Now, if we wanted to draw another pair of angles and say that pair of angles were congruent, we'll call this angle XYZ, and I'll draw another one over here, and we'll call this angle JKL. And I wanted to say these two angles were congruent, but they weren't congruent to angle ABC. We could put two arc marks to indicate that angle XYZ is congruent to angle JKL. So those two angles are congruent, but we would say angle ABC is not congruent to angle XYZ because ABC has one arc mark and angle XYZ has two. Now let's look at the definition of the angle addition postulate. If S is in the interior of angle PQR, let's draw that out so far. So here is angle PQR. S is in the interior. We discussed interior angles versus exterior angles yesterday. S is on the interior, and we draw a ray from Q through S. We now have two new angles in addition to angle PQR. Those two angles are PQS and angle SQR. Those two angles, when added together, give us the whole large angle of PQR. Here is the official definition of the angle addition postulate. Notice we can abbreviate the angle addition postulate with the angle symbol. Addition can be abbreviated ADD with a point behind it, and postulate can be abbreviated POST with a point behind it. Let's practice using the angle addition postulate. In this question, we learn that the measure, this tiny m stands for the measure of angle, remember that's our angle symbol, DEG is equal to 115 degrees. So the whole wide angle here is 115 degrees. That's the whole big angle. And we know the measure, remember this tiny little m here stands for measure. The measure of angle DEF, so this is the inner angle here, DEF, this angle right here measures 48 degrees, and we want to find the measure of angle FEG. So pay attention to how we are abbreviating, please, because we are going to be using those abbreviations ourselves. So we have FEG is what we're looking for, this inner angle as well. What does this angle measure? So we can set up the angle addition postulate. We know that the measure of angle DEG, the whole big angle, is equal to the two smaller angles added together, DEF and FEG. So let's fill in what we know. We know DEG measures 115 degrees, and we know that the measure of angle DEF is 48 degrees, and we want to solve for angle FEG. So we take the larger angle and subtract out the smaller one. So 115 degrees minus 48 is 67 degrees. Let's look at a second example. In this question, we find that we have the measure, remember that tiny little m in front of the angle stands for measure, of angle, that angle symbol stands for the word angle, x, y, z, so the whole big angle, the whole thing is 121 degrees. We know that the measure of x, WY, the first of the smaller angles there, measures 59 degrees. And we want to find the measure of YWZ, so this smaller angle right here. What does that angle measure? Now, we were talking about if you know the whole big angle, you just subtract out the smaller angle to find the remaining angle, and that would give you what your remaining angle would be. So I'm just going to rephrase this. Instead of saying the whole angle is equal to the smaller plus the smaller, this is the whole angle right here, right? This is the whole big one, XWZ, minus the piece that we know. The whole big angle minus the piece that we know. Okay? So what are those values? It's 121 minus 59, and that gives us 62. So the missing angle there is 62 degrees. Our next vocabulary word of the day is an angle bisector. The word bisector means to divide in half. We're dividing the angle in half. So if we're going to divide anything in half, we're going to get two equal parts. So 100 split in half is 50 and 50. 20 split in half is 10 and 10. 5 split in half is 2.5 and 2.5. So we just take the value and divide it by 2. So the angle bisector is a ray that's cutting an angle exactly in half, creating two congruent parts. So in this case, we have ray. Notice there's a line with an arrow indicating that we're talking about a ray. We have ray JK coming through and cutting this blue angle here, the angle LJM, and it's cutting it in half. So if I was told LJM, that whole measure was 60 degrees, what would each of these pieces measure? Well, we would say 60 divided by 2 because we're just splitting it in half, and we would get 30. So angle LJK is 30 degrees, and angle MJK is 30 degrees. Now let's take that information and see if we can use that information in finding missing values. So we have KM is the bisector, or it bisects angle JLK. So you can see this JLK is the whole big angle, and ray KM just shoots right out of there and cuts that in half. So I know that angle JKM is congruent to angle LKM. So the question tells us the measure, that little m stands for measure, the measure of angle JKM is 4x plus 6. And the measure of angle MKL is the equation 7x minus 12. Now we just said that these two angles were equal to one another. So we can set them equal. We can say 4x plus 6 equals 7x minus 12. And then we can use our skills to solve multi-step equations to solve for our missing value of x. So we can subtract 4x from both sides. So we get 6 is equal to 3x minus 12. We can add 12 to both sides. So we get 18 is equal to 3x. We can divide by 3. So we find that x has a value of 6. That is not what the question asks for. The question asks us to find the measure of angle JKM. Now, the measure of angle JKM is the equation for x plus 6, but we must solve that equation. Now, we know that our x is 6 now. We just discovered that was 6. So we can say 4 times 6 plus 6. So 4 times 6 is 24 plus 6. So 24, the measure of angle JKM, is equal to 24 plus 6, which is 30 degrees. And that's your final answer. Let's look at one final example. Here we have the angle PQR, and it says that QS is the bisector to angle PQR. So that means I'm going to take my angle PQR that I just drew and do my very best to try and split that in half so that we know angle P, the measure of angle PQS, is equal to the measure of angle SQR. Now let's look at the other information it tells us. It tells us PQS, this angle right here, measures 5y minus 1. It also tells us that PQR, the whole thing, I'm just going to write it down here, is 8y plus 12. Well, how do we go about solving that? I was not given anything for angle SQR. Well, we were told that QS is the bisector, so these two angles are equal. So I can call this angle 5y minus 1 as well. And now we can use the angle addition postulate and say the first angle, 5y minus 1, plus the second angle, which is also 5y minus 1, is equal to the whole kit and caboodle here, 8y plus 12. And now we can combine like terms on each side of the equal sign. So 5y and 5y combine to make 10y. Negative 1 and negative 1 combine to make negative 2. And then 8y plus 12, that's already simplified. I'm going to subtract 8y from both sides. So we get 2y minus 2 equals 12. I'm going to add 2 to both sides. So we get 2y equals 14. Divide by 2, so y is equal to 7. So we found our y. That's not what the question is asking us for. It's asking us to find the measure of PQS. So I'm going to come up top here and say the measure of angle PQS is equal to 5y minus 1. Well, the measure of angle PQS is equal to 5 times 7 minus 1. 5 times 7 is 35 minus 1, which is equal to 34. So the measure of angle PQS is 34.